Welcome to MPSA's Machine Safety Webinar Series. I'm Marie Yolstead, your moderator for today's session, Understanding Your Facility's Machine Safety Needs. Like all of the programs in our series, today's session will focus on machine safety topics that often begin as a question we encounter when working with our clients. Our goal is not to make you a machine safety expert, but to familiarize you with the technology, industry standards, and regulatory requirements that may apply. Most important is that you leave this session with an increased understanding of machine safety and know where you can find additional guidance when needed. Presenting today's session are David Kerr and Jamie Gaehring of MPSA's Machine and Process Safety Assessment Group. David is MPSA's EHS Program Specialist with over 35 years of industrial safety and loss prevention experience. Jamie is MPSA's Senior Controls Engineer with 45 years of machine automation and safety design experience. David will begin today's session by discussing the challenges and complexity of machine safety.
Why is machine safety so important? Well, first and foremost is machine safety instances often result in serious, if not fatal injuries. These are just not soft tissue injuries, cuts, bruises, skin irritation. These are injuries that require emergency treatment, hospitalization, amputation, and unfortunately in some cases result in occupational fatalities. However, it is important not to wait for machine accidents to occur. Encourage your employees to proactively report and investigate all close calls and abnormal machine operations. These events are often accurate indicators of the more serious events that may occur in the near future. Machine safety incidents can be very traumatic and have a lasting impact on employees, especially those employees who have firsthand witnessed such traumatic events. Machine safety incidences can also create doubt in the minds of employees who must continue to operate similar machinery. Due to the seriousness of machine safety incidences, machine safety continues to be a priority for both compliance and insurance inspectors. Due to this increased emphasis, machine safety continues to have a high potential for regulatory citations and fines. As can be seen on the right-hand side of the slide, both machine guarding and lockout-tagout continue to be one of the top 10 most cited violations by OSHA. But we all know that machines are key to revenue generation, and any safety incident or upgrade may impact critical production needs. Why is machine safety so complicated? Well, quite frankly, solutions can be costly and complex. Upgrades must be done quickly and often can't impact production or quality. Machine safety must address normal production operations as well as hazardous energy control during lockout-tagout conditions. Machine safety often requires the control of several hazardous energy sources, including electrical, hydraulic, pneumatic, mechanical, chemical, thermal, gravity, or stored energy. Machine safety may also be complicated due to one of the following reasons: a recent near-miss or serious machine-related injury, the OSHA, ANSI, ISO, and NFPA safety standards are just too confusing, a third-party risk assessment has identified several risks but provides no ideas on how to fix them. Machine safety may be complicated by a variety of concerns by various stakeholders in your facility. Often these are valid yet difficult questions to answer. Plant management may be concerned over the potential for a future regulatory inspection or audit. Your procurement department may advise you that the original equipment manufacturer is unable to modify your existing unsafe machine. They say that it will need to be completely replaced. Your engineering manager may determine that the safety upgrades may cost more than the machine is worth. Your control engineering group may be concerned about the safety reliability and safety controls. ensuring that they're ISO compliant. Operations personnel may be concerned with reduced production and increased cycle times. Maintenance may be concerned about restricted access and may have concerns that maintenance and repair may become impossible. And the quality organization may be concerned with any equipment or processes that are validated or qualified and having appropriate management of change documentation to support any such changes. As you can see, machinery safety can be very complicated for a variety of reasons and concerns expressed by a variety of stakeholders within your organization. Due to this complexity, we often refer to this as the machinery safety gray space. Despite this, as an employer, you are still obligated by law to provide safe and compliant machinery. Let's now talk about some practical steps your organization can take for implementing a machine safety program. Let's continue discussing how to implement a machine safety program. Here are some key considerations. Identify the scope, objectives, authorization, and priorities for your program. As with all programs or improvement initiatives, having a clearly identified scope, objectives, authorization, and priorities is critical for program success. Implement a machine safety advisory team with defined responsibilities and shared machine safety knowledge. Think of this as your gray space team. Having this diversity of expertise, knowledge, and input will only ensure a much more successful outcome. Equipment inventory and machine documentation will be critical. Collection of this information will be necessary prior to conducting any risk assessments, designing or fabricating improvements, or any installation of safety solutions. Select a hazard identification methodology. It may be necessary to reach out to regulators, your insurance company, or your company's health and safety organization to determine which methodology is most suitable for your operations. Feasibility review and financial guidelines are critical for the success of any program. Such guidelines are necessary to allow plant management and senior management to understand the cost-benefit analysis. When implementing a machine safety program, proven and successful programs have often followed a machine safety process similar to the graphic shown. These processes typically include 6 key elements as shown. First, the hazard identification, followed by the design and fabrication, then the installation and validation, and lastly, the training of both operators and maintenance personnel to maintain these devices. When implementing a machine safety process, it is first critical to understand, does your organization have the internal resources needed, or must they partner with an external resource to assist with some or all of these key steps? Lastly is the management of change and mechanical integrity procedure. It will be critical to have such programs in place to track and maintain the safety upgrades made to your machines and to ensure that any future change is consistent with minimizing or reducing hazards for both a safe and compliant installation. So how did you get started? As noted on the prior slides, collaboration with stakeholders such as operations, maintenance, engineering, and EH&S is necessary to acknowledge everyone's concerns. Type of machinery. Often off-the-shelf guarding and simple control devices may be suitable for upgrading machine shop equipment. However, larger production, packaging, and material handling machinery may require a fully customized solution. Conduct the machine hazard identification to identify both the known and the unknown hazards. Understand all operational and maintenance needs. Identify lockout-tagout versus normal machine operation needs and solutions. Identify and control all forms of hazardous energy. Perform stop time analysis to determine adequacy and proximity of existing access control devices such as light curtains and scanners. Based on the above findings, introduce solutions, whether guarding or safety control solutions, to reduce or eliminate the noted machine safety risk. Finally, ensure that all solutions are user-friendly and have no or minimal impact on production.
Now we will talk about key considerations in recognizing safety devices on your machinery and if they have been properly applied. Lockable zero energy state isolation devices are used for lockout tagout. Some common lockout isolation devices are electrical disconnect switch for isolating electrical energy, the item on the right, and compressed air manual isolation device and dump valve on the left. Your barrier guarding, which needs to be durable and tamper resistant, it needs to prevent operators from reaching around, under, through, or over your fixed guarding. In this case, this is a wire mesh guarding. This is also called separating guarding because it is a physical separation between the hazard and an operator. The tool shown on the right was developed from minimum safe distance charts found in ISO 13857 standard. It confirms the minimum safe distance to the hazard based on the guard openings. Now we'll talk about reliable safety rated control devices, the first one being safety light curtains. A safety light curtain is a presence sensing device that can detect when a person is between the light curtains, as are safety laser scanners. Like separating guarding, a minimum safe distance calculation is required. Now, this device is a non-contact interlock RFID sensor. RFID stands for radio frequency ID. These are used for separating movable guarding, and it protects personnel from reaching the hazard. The non-contact feature, if properly installed, should greatly reduce or possibly eliminate any mechanical failure. Being an electronic device provides for long life expectancy. Now, this interlock switch, is very similar to the last one. It's also RFID, and it's a door switch. The difference here is that this is also used for movable separating guarding, meaning access doors and the like. It protects personnel from the hazard until the hazard has been removed. Most common use is where there's a long rundown time, let's say, of a motor-driven machine. And this prevents the operator personnel being able to access the hazard by keeping the door locked until that machine is in a complete standstill state. The programmable safety controller, these allow for flexible safety control systems. They're more cost effective than using several safety monitoring relays when multiple input device types and multiple stop conditions are required. Now, this is an emergency stop. I'm sure you've probably seen them in your plant. I hope that you have them in your plant. Emergency stops, though, are a secondary protection. Now, some of the standards listed here, for instance, the ISO 13850 and IEC 6947-5-5 are standards for the principle of design of the hardware itself, the e-stops. All industrial machines require an emergency stop, as is found in IEC 6204-1 and NFPA 79. One of the last things to look at is your testing and confirmation of machine stops if you're using safety light curtains or laser scanners. The formula shown in this slide is actually an ANSI formula for minimum safe distance found in ANSI B11.19. The equivalent international standard is ISO 13855, and it has a very similar formula. These formulas had to be calculated to know that the light curtain or scanner is positioned in such a way that the operator cannot reach the hazard before the hazards come to a complete stop or standstill state. And the last part of the process of designing a safety system is validation, testing, and maintenance. Validation is a necessary part of implementing a machine safety system. Validation itself is a functional testing of the safety field devices and the pilot devices. And during that validation, you introduce faults into the wiring to confirm the proper response of the safety system. You force faults into the monitoring circuits, things like the external device monitoring contactors, the EDMs. Now, a safety control engineer will develop a valid plan to perform the validation of the safety system. It confirms that the installed system has been properly designed and installed to satisfy the performance level and category architecture defined during the risk assessment. Everything goes back to the risk assessment. This validation must be performed prior to releasing the machine to production. The documents down at the bottom of the slide are examples of validation checklists and validation summary reports. And these should be generated to confirm to the performance of ISO 13849-2.
Thank you, Jamie, for sharing your expertise. It looks like we have some questions from our viewers. So here's the first one. What is the best way to educate my staff to have the skill level to confirm that our machine builders and in-house maintenance people are using the right components to give us an OSHA compliant solution? That sounds like a question for you, Dave, since it deals with EHS issues.
Yes, Marie, and that's actually an excellent question. Actually, attending programs much like this and other programs offered by safety equipment or safety component manufacturers and turnkey machine vendors or safety machine vendors is really your first step. Some of those programs are offered for free, and other of those programs, there may be a fee associated with them. Also, to ensure that your machine builder has expertise in machine safety, you might want to establish and share some of your internal machine safety standards and include those in your contractual agreements as references to reflect either the regulatory or the consensus standards that you want your machine builder to observe. There's also a few training and certification programs available specifically for machine safety control engineers or in-plant maintenance personnel. And these types of programs really may be appropriate for folks who have those responsibilities in your plant, whether it be your instrumentation group, the automation, or the control engineering group. And these programs typically last 3 to 5 days, and there's a certification available after passing the examination. But there's a lot of new technology and a lot of new products in this space, so having that in-house expertise is really a good, I would say, actually a good opportunity for any company to look into.
Okay, thanks, Dave. Here's another question. How do I complete a stop time study to know if I can use a light curtain instead of the closed fence with doors? My operators need constant access to load and unload parts. Jamie, I know you've done plenty of stop time studies, so why don't you field that one?
Yes, Marie, thank you. There's 2 reasonable ways to approach this. One would be to perform a calculation found in ISO 13825, but you must know the response time of the machine. The response time of the safety light curtain and intrusion distance. That's a function of resolution, the distance between the LEDs and the safety light curtain. The standard formula is pretty simple. It's S equals K times T plus C. You can also back into this by determining what is the maximum space you have and calculate what the stop time needs to be, but you still need to know the actual stop time of the machine. Or have a stop time analysis performed by a calibrated stop time analyzer, and there are companies out there that can perform this service for you.
Okay, thanks, Jamie. I think this next question is also a good one for you to answer. I am confused when my engineers argue about OSHA compliance, safety categories, and performance levels. I would like to talk intelligently about these things, but I do not know the difference. I'm only 3 years out of college and want to contribute in these conversations.
Well, let me start out with saying that OSHA does not address how to determine the safety categories or performance levels. They are defined in ISO 13849, but rather than just purchase the standard, it's wise to attend a training class. Some component distributors, safety product manufacturers, and safety service providers provide training sometimes with a fee. You can sometimes find a beginner's training class at no charge or search the internet for free webinars.
Okay, Jamie, good suggestions. Here's the next question. Can I do a risk assessment myself, or do I have to pay for a safety professional? My insurance company says I can hire them to help me, but I don't think they know anything about machinery. Well, Jamie, I know you're very familiar with risk assessments, so why don't you field this one?
Okay, thanks, Maria. And it's a good question, one that we get often. You can do the risk assessment yourself, but you need to have a knowledge of consensus standards, such as ISO 12100, or another one is robotics. It's an RIA TR R15.306 task-based risk assessment methodology. So one or the other, and there are others out there. I would suggest you work with a service that performs risk assessments, at least for the first time, to understand how to recognize the hazards by their tasks.
Okay, yes, that's very good advice. Here's the next question, and I think it's another one for Jamie. I have a switch on my guard door that stops the machine. My local salesman is trying to sell me a switch that costs 3 times as much, but I see no real difference in the end result. My machine still stops.
Okay, well, that's a pretty common observation. Let me try to explain why that is. What you might not see, but need to have to satisfy a recognized industry consensus standard is third-party certification of the hardware as a safety-rated device and proper architecture and design of the safety control system to conform to the standard. Yes, the machine might stop now, but what about the next time? The proper hardware selection, process, design, and validation, that's required by a recognized industry consensus standard like ISO 13849, is that if a hardware failure occurs, the machine does stop in a safe state and cannot be restarted until the failure has been corrected. That's the difference.
Okay, yes, it's important to use safety-rated devices for a compliant solution. Here's the next question. We had a safety training at our plant, and the speaker talked about control reliability, but never explained what that is or how I can measure it. I want to know if my machines are safe. The speaker compared it to a double cheeseburger. I'm so confused. Okay, I'm confused too. Jamie?
Well, that's interesting. Well, even I'm confused with comparing it to a double cheeseburger. But places you can look and where it's defined is in ANSI B11.19. That defines control reliability as the capability of the machine control system, the safeguarding, other control components, and related interfacing to achieve a safe state in the event of a failure within the safety-related functions. Now, ISO 13849 has a similar expression, which is well-tried components that they define as, 1, they have been widely used in the past with successful results in similar applications, and 2, they have been made and verified using principles which demonstrate their suitability and reliability for safety-related applications. But I think the bottom line is you can be confident that the control hardware will respond in an expected fashion because it was designed and selected for the required application.
Okay, one last question. And Dave, I think this is a good one for you. Who is legally authorized to come into my plant and tell me I need to upgrade the safety parts of my machinery? Most of my machines come from Europe and they have a CE mark. Shouldn't this be enough? Isn't the safety on their machines their builder responsibility and not mine?
Marie, the famous CE mark question from folks who have European manufactured equipment. Yeah, this is a confusing one, but the way I like to answer this is that the CE mark often really doesn't help you as the user to understand the how or what that was covered in the manufacturer's risk assessment of your machine. And because of that, you don't know if the manufacturer has properly assessed your machine exactly the way that your company or your operators use your machine. So with that said, the better approach really for the US-based companies is to conduct their machine safety risk assessment, again, using one of the recognized methodologies that Jamie had just noted in one of the prior questions above. Then you can design and install the guarding or the safety control solutions specific to your machine and to the unique operations and way in which you use it. But as the employer, you're going to really want to keep this machine-specific risk assessment on file. That way there you can show the machine safety solutions that have been applied and also include any of the validation criteria that may have been conducted, again, as Jamie has already noted just in one of his prior answers above.
Okay, well, thanks to you both. And we also want to thank our listeners. If you have any questions about your machine safeguarding application, you can contact us using the phone number on this screen or by visiting our website. Thanks again for listening.